and turning off the high def, and it seems like it goes a lot quicker now. Just recording in standard mode because it was uploading in standard definition anyway, which is sad because you got a high def computer and it turns it into standard def. Hey, all right, we got one more tool here, and then we'll. So what my idea was is we bounce through all the concepts and we go back and review the next we'll do polar milling next, and then we'll back up and do the other YC project, and then lastly we'll do the last polar milling project, and then you guys should be ready for the final at that point. Okay, so this is going to be T505, which is our radial tap. That's going to be a 1/4-20 tap. And here's the deal. This is gonna be part of your homework, and you can basically, just to get you in the habit of copying and pasting, you can copy and paste this whole radial drill bit and paste it down here, and then you'll just have to change the G codes and the feeds and speeds. So remember that there's a tapping example in the book here. I can find it. Drill with the well. Pack drilling with IJK. Here's your radial tapping cycle. So I don't think they're using Y here. It's going to be a lot like this on page 36 here. And notice that the feed rate is in inches per rev. All right. So by telling it G99, it's up here, they're telling it G99, and that is what is causing it to read the inches per rev. And the reason they're doing inches per rev is because it's got to be synchronized with the spindle. So in this case, your RPM doesn't really matter that much, but your feed rate will, which is basically going to be your thread pitch. So for 1/4-20, your feed rate is going to be the 1 divided by 20. And so just copy this part. Well, copy and paste from the drill, and then change your codes to match this with the right feed rate, and then that'll be that. So all we got to do now is turn and cut off, which I like to review because some of you guys like to cut your parts off without chamfering the back of it, and that's kind of a no-go because then you got to go and deburr all your parts when the lathe could have done it for you. Sip of coffee to keep on moving here. Also going to be really important to turn all your codes off, like G18, G99. These are all going to be important to go back to turning mode. So we'll give it the turning codes again: G0, G97, G99, which is basically rapid. Constant surface feet off, and inches per rev. E606. No, that's probably not. Let's just do this. T606. This is going to be our 1/8 cutoff tool. And we'll program farthest edge. Turn my caps off. V is farthest. edge. And the reason I want to do that is because that makes me not have to calculate the cutoff tool into my overall cutoff. Because normally you'd have, since you got 3.4, you'd have to tell it to go Z minus 3.525 because the back of the tool is actually Z0. So if I make the back of the tool, if I tell it to go Z0, it's going to be 1/8 of an inch into the tool. So it's not the greatest, not always the greatest way to do it, but it's a lot easier to program from our perspective. Okay, T606, and we'll say G0, G97, G99, S500 RPM, M3. So we're back to spindle mode. And we're just going to wrap it down to Z.1, X2.5, turn on the coolant, M8, and at that point we're right in front of the part right now, and so I'll just wrap it right down here. And what my strategy always is for cutting off is to take my cutoff tool into the part a little bit, then I'll wrap it out and over, feed in, and then finally cut that angle because you want to always cut a little bit of a clearance in here because you never want to be feeding the cutter, the parting tool at an angle into the part without a clearance there because they're really not designed to do this. All right, Z minus 3.4. And since I took my offset off the back edge of the insert, I can tell it to go straight to that. And I'll say G1. Let's just go X1.9. F.003. I usually like to kind of go easy on my cutoff tools because they break all the time. And then we'll say wrap it out, G0, X2.5. Plenty of clearance there. And now I'm going to move Z, and we'll just say we're going to cut, most of the time your dog bone or your cutoff insert is going to have about a 15 thousandths radius on it. So if you try to cut a 30 thousandth chamfer, it's really going to end up being about 15 thousandths because of that radius. So we'll go 45, we'll go 60 to make it easy to calculate here. Z minus 3.340. So 3.340, 3.4 minus 0.060 is, I'm sorry, 3.4 minus 0.060 is, excuse me, 3.340. And I'm going to feed G1 X 2.105. So the reason I say that 2.105 is if my offset was a little bit off on my cutoff tool, that would still keep it off the part so that it wouldn't raise up a burr by actually engaging material there. So I'm just staying 5 off the part. Since I'm cutting a 60 thousandth chamfer, it'll really be 55 now.
Do we need another feed rate since we
No, I'll just leave the feed rate.
Technically cancel the last one?
I'll just leave it at 0.003.
Did we cancel it with the G?
Do what?
Doesn't that get canceled with the G0?
No. Now, once you give it an F, anytime it reads a G1, it'll pick up the last F that it read. In fact, if I didn't have this in there, it would go back and read whatever this feed rate was. So if that happened to be 4 inches a minute, if that happened to be 4 inches a minute, you're going to have a really big problem down here because it's going to try to cut 4 inches per rev. That's a crash.
That's not good.
I know that because I've done that. I've left that at feed rate and had a crash that way, so that's something to really got to watch out with these live tooling lathes. That's a common problem. All right, so now I'm going to cut my chamfer. 2.105.
Couldn't do jumping in into a program. I don't get what that means.
Couldn't do jumping into a program. Not having feeds everywhere. Again, it's just gonna, if you don't have a feed rate, it's gonna read, no matter if you're jumping around in a program on a Haas, it's gonna go back and do a restart and read the last feed rate that you put in there. If you are on a Fanuc, it's just gonna pick up the last feed rate that it read. So if you were moving around the program, you'd want to make sure that your appropriate feed rate was active. All right, so 2.105, and I gotta pull out my calculator for this. 2.105 minus, we decided to do 60 on the chamfer, so 120.
Yes.
0.120, so it'd be 1.985. At 1.985 Z minus 3.4. Okay, so there's my chamfer move. And so now I'm just going to probably, sometimes it's a good practice to come over here and face it down 5 thousandths past and then take another face, back face, because you'll sometimes get a better finish that way. But I'm just going to go ahead and take it down. With a G75, we'll create a back cycle. X.2. Well, you know, we also need to like turn on G96 here. We want constant surface heat.
Oh yeah.
S, like a little bit slower though. Be easier on the parting tool. 200. So I'm just going to take it down to X.2 because this is a big chunk of material and we don't want it falling off and crashing into the chip conveyor or anything. Just have to take the part out and saw it off or something. G0. Now this G75 will leave it, it'll back down to 0.2 and then it will leave it at 1.985. So we're going to have to manually retract it out even farther, which is good practice anyway. X2.5, M9, X base, and then we'll say Z1.M5, turn the spindle off, G28, and M30. That's the wonderful, beautiful YC program at your service. So that's kind of the homework.
Percent.
Is the you want to add tap, which is again this toolpath up here, the 203 toolpath, just copied and pasted with the codes from page 36 in the live tooling manual. And if you still have issues with that, just feel free to text me about it. I'm going to save this and I'll upload it. That's weird. Save this in my file here. Bear with me. Oh my goodness. Definitely missing my mouse this morning. And yeah, it's lathe. I thought I already had it saved in there. Oh no, that's it's trying to save the other thing. Control save. There we go. You guys left. Now we're going to talk about polar milling because class is 2 hours. I didn't know everybody was signing. The doorbell doesn't ring when everybody signs off.
No, I think only a couple people left.
That's all right. We're going to keep rolling with this. We'll go till 10. We'll talk about polar milling, and then we'll talk about the assignment, and then we'll actually start the program next week. Let me find it. Polar milling is a whole different animal because you're using X and C to create movement that's a lot like X and Y movement. In other words, your X will move in and out this way while C is rotating this way. There will be no actual Y movement, but we will program X and Y movement. And it's a pretty cool thing to watch. Unfortunately, we won't get to do that this semester. Y-axis programming, milling flats with the Y-axis. There's a whole different side of the machine tool for C-axis or polar milling. Oh, this is what I was talking about earlier, calculations for feed rate in degrees per minute for the C-axis. Remember I was talking about the F999? It does 999 degrees per minute because it can't go to 1,000 or 10,000. 999 is the fastest it goes. Some more examples. These are actually... They give you the solutions to the exercises, which is pretty useless. You can go to the back of this book and, yeah, it must be up here somewhere. I'm pretty sure it's G112. Let me Control F. G112. That's weird. So there's 20 instances of it. All axial or face operations using G18 to properly work. The only face working operation not using G18 is the G112. So that's kind of weird because we will actually use G17 when we're using G112. It's also listed on our cheat sheet. Keep going here. Which is this. Hey, somebody came back.
Mike's back.
G112 is our Cartesian to polar. To me, it's really the opposite. On a Akuma, it's G136 and G137, but it does the same thing. So here we'll kind of start talking about this a little bit. There's way more than 3 people here.
That's just the overflow. But somebody else has a mic.
I think Chris is just trying to get me to stop early. Hey, there's only 3 people left. Can we go? I don't mind if there's only 1 person, really. Okay, so the way this works is, again, we're going to just use X movement and C movement to mill features on the face of the part. And polar coordinates are specific to rotary applications, so it's only on this plane will we do polar milling. So think of it as a face operation. When you want to mill a square or a rectangle or a hexagon on the face of a part, you'll generally use G112. Now there's times where you could potentially use a y-axis instead of the G112, but the idea is that you would always try to use the Cartesian to polar milling because some lathes will have a C-axis and not have a y-axis. So anytime you can use this G112, you're opening up opportunities to use it on more machine tools. So it allows the G112 to transformation feature allows the user to program subsequent blocks in Cartesian X and Y coordinates, which the control automatically converts to polar XC coordinates. So with the Mories, you actually program X and C movements. With the Haas, you program X and Y. And with the Mories, X is on the diameter and Y is on the center, on the radius. With Haas, they make the X and Y both from center. That makes it pretty easy to program. I guess the best way to look at this is just looking at an example. With the polar milling, we always use G41, and the reason for that is we can program the exact geometry of the feature that we're programming instead of having to figure in, the diameter or the radius of the tool, much like on a milling machine. Feed rates. See, note that no y-axis movement is made when using G112. All the motions of the machine are in X and C. And it's kind of hard to wrap your mind around, but as the tool X basically moves in and out, or in plus and minus, while C is moving forward. And it kind of works like as C is moving, which is weird because this camera is backwards to what I'm actually doing. So it's not helping me to, that's not helpful. I'll probably look for some YouTube videos that show polar milling working so that when we're programming it, it won't be confusing as to what's actually going on. So here's an example of milling a hexagon, which isn't a really super great example, but because they have a little radius on each one of these corners, which makes it really confusing to try to read. But the nuts and bolts of this are some of these codes are going to be the same, like engage C-axis. We're going to zero C-axis out. We're turning on the cutter because of live tooling. You're going into inches per minute. Now the difference is here is we're going to use, this is the only time we're going to use G17 on the lathe at all. And if you look at your cheat sheet, I guess Y-axis milling uses G17 as well. So anytime you're milling on the face, it's going to be like G17, which makes sense because it's XY mode, right? But G112 is the actual command that says, hey, you need to start calculating my X and C moves for me because I'm going to program X and Y.
Ethan says, try and find a Titans of CNC video.
Oh, yeah.
That guy is crazy.
Yeah, he's good. Yeah. In fact, there's a Kennametal seminar with him that I'm going to watch next week, webinar. So we're going to a clearance plane, feeding down. So once it reads this G112, you'll notice everything from here on out is X and Y moves. And I don't really like this. I wish they would have just programmed a square or something so you could, like, if this were a 1-inch square, you would tell it to go X. Everything from center would be X minus from here. So if this were a square, you would have X minus 0.5, or a 1-inch square. You have X minus 0.5 this way, X plus 0.5 this way, Y plus 0.5 going up, and Y minus 0.5 going down. It's pretty much just that simple. So notice they're kind of turning on. Oh, they didn't turn on. They didn't turn on the. Oh yeah, there's G41. Turning on the cutter compensation, so you would have to put the diameter of the cutter into the offset registry of the tool for this to work properly. So all that's just cutting geometry, and then G113 cancels out the tool side, the G112, the bookend, and then everything else is just pretty much disengaging the C-axis. and all that. So our project is the axis. By the way, if you want to watch the UJA lecture, I'll publish this after we're done here. It would be off this tab. And it should be, when you open yours, you should have your videos will be right there. Now I have to go back to the courses. By the way, another good way to log in is this pink bell here. When it's pink, that means you have a class that day. You can launch it right from there. That's what I've been doing anyway. And then the video, I will post it right here, and I'll kind of investigate that need for a password. If you need a password, I'll create one. But it was working fine. Okay, so we've got Polar Milling Project, which is pretty easy, really, but it shows you, it demonstrates how we can. We'll rip through this pretty quick next week because we're basically just milling in to the side, milling this circle, then we'll come out, turn it off, and then come back in and mill the hexagon. And there's also a square, and we'll have all that ready to go next week. Just a little ditty on if you wanted to program this part in Mastercam, doing the same thing. I mean, I might just touch on this and we'll start next week showing you more. It's kind of a pain to do when my mouse isn't working. Yeah, I think we'll just start next week. I'll show you a quick way to write the same program for this in Mastercam as kind of since we don't get to actually operate the machine tools, it'll be fun to watch Mastercam actually cut the part for us. And I'll show you how to chain these contours, call up a live tooling toolpath, and we'll actually post it and see what it looks like. So I think with that, we'll where's my screen?
And y'all need to get some microphones.
Yeah, I mean, I'm good with if people want to chime in and contribute or ask questions. Yep. Time to go get another mouth. Yeah, we'll start next week with the Mastercam thing. I'll show you guys how to actually program that part. And if you've downloaded the HLE version, you'll be able to pull that part into your HLE and practice doing the toolpaths yourself. You won't be able to post the code because HLE won't let you post code. But back to the matrix.
You just need like earbuds.
Yep.
Something with earpiece and microphone to plug it into your computer.
I will say that some people will not be able to use microphones because it only allows 5. So
we can take turns.
all right, folks, I'm going to